Hello, we're going to now do episode 6, which is about plotting. So if you're making a simulation or you're analyzing data, you have to present your data typically to somebody, or you want to look and see what some of the results are. One way you do that is by plotting something. So come on. So in this episode, we'll learn plotting the function of one variable. 2D plots, which can be semilogx plot, loglog plots, or just linear plots, titles, axis labels, how you do multiple functions of one variable with legends, some things how format your plots like grids and colors and lines and points. We're going to talk about how you can plot a 3D line in space and how you plot a surface. These are all ways you might present data from either a simulation or an analysis. So we're going to start talking about an example here. We're going to just plot basically a sine function. So we're going to do a sine of 0 to 2 pi. And this is the code that we use to do that. The figure function creates a new figure to plot something on. And whenever you do a plotting operation, it always operates on the last figure that was selected. So if you want to do something on one figure and then on another, what you can do is you can put a label on them by saying figure 1 to create a figure with label 1. And then every time you say figure 1, it'll go back to that figure if it already exists. The plot function then plots on the figure that was created. So the plot function can take 1 or 2 arrays as input. And now we're just going to show how that works. So now we're going to create that function. So we'll just have x equal 0, let's say pi over 50 to pi, or 2 pi. And we'll say, okay, let's do a figure. That brings a figure up. We're going to move that over here so you can see it better. And then we're going to do plot x and sine of x. And that plots the sine function. Now if I wanted to plot the cosine function, I can just do this. And it now it replaces the sine function with the cosine function. You also could just plot the function itself, but then it would be plotted as a function of the index of the array. So that just says there's 100 points in this array. So you really want to do the plot. For something like this, you'd want to plot both the x and the sine x. Or you can plot any function you want. Plot x tangent x. And that does that because there's some, obviously there's some places where tangent x is not defined, but because it's sine over cosine, so wherever the cosine is 0, it does some weird stuff. Goes to infinity, that's why you can't see it looks like a straight line. This is actually not a straight line, but because of these big spikes, it looks like one. You could plot other functions. You could like plot x squared. Okay, dot x squared. And that's you can do all of that. Okay. So we just did the demo of just plotting some functions. Now we're going to talk about semilog plots. So in this case, you want to, let's say one axis has a very wide range of variables and the other range doesn't. So you might want to plot the log of that function on one axis. And that's called a semilog plot. there are two functions that produce semilog plots. Not surprisingly, there's semilogx in case you want to basically compress the x-axis, or semilog y if you want to compress the y-axis. So let's show how that might work. Okay, let's look at, say, something like, let's go x equals, I don't know, 0 to, I don't know, 10. Let's let y equals, let's say, the exponential function x of x. So we'll do figure. Okay, we'll move this back over here so you can see it. Plot x, y. So you can see that it's sort of compressed. You don't see what's going on down here. But it might be more interesting to you too if you did a semilog y plot. So this is plotting the log of the function x, y. Semilog y. And that looks like a straight line. Well, that makes sense because sort of the log undoes the exponential function, so it should look like a line. You can also do, if you wanted to do the opposite, say plot yx. That looks kind of weird, so now let's do a semilog x to make that, see what that looks like. Also looks like a line. So let's do something like this, y equals x cubed. Oops, what I did wrong was I didn't put a dot there. Now we'll do plot x, y. Again, it sort of looks like what you might expect the cubic function to look like. But if you did a semilog, log y of xy, it looks, whoops. Okay, yeah, so there was a problem here because there was a 0 in there, but that's a small thing. So it looks a little bit different, but you can do that. Okay, now we're going to look at loglog plots. It's the same sort of thing. So in this case, both variables are plotted as the logarithm. So, and you would use the function loglog. So let's do that now. Okay, we're going to do something similar. We're going to do another clear all, get rid of all the variables, close all, get rid of all the plots. I'll clear out the screen too. CLC will clear out the display area, or the command window. So let's do something like, oh, I don't know, x equals, oh, I don't know, exponential of 1 to 10. And let's y be, I don't know, something x squared. I have no idea what this is going to look like, but let's see. Okay, so you figure. Move this back over here. Let's see what that just looks like. Plot x, y. And it looks like, yeah, that doesn't look that unreasonable, I suppose. And now you can do a loglog of x, y. And it just sort of looks like a straight line, which is, not too surprising. Let's change this a little. Let's say y equals x, I don't know, to the 3/2 or something weird like that. And see what that looks like. Just a different slope. It's just same line, different slope, as you probably would expect it to look. Now we're going to talk about making your plots a little bit more pretty, I guess. So the title puts a title on a plot. So if you did what we did with the sine function, you would like a title, plot of sine x versus x. And we'll do that now, show you how that works. So the title function puts a title on the graph. Nothing too surprising there. Okay, so now what we're going to do, x equals 0, pi over 50 to 2 times pi, y equals sine of x. Come up with a figure. Then we're going to plot x sine x, and that looks like what you expect it to look like. Then you will put a title on it. And you're going to put a string, so it's single quotes, sine of x versus x. So if you put a plot like that on all you're saying, when you say versus, you say what variable it's being plotted against. And that puts the title on the plot. Fairly straightforward. So another thing you want to do when you're making plots is you want to put labels on the axis to say what they are. So you have the functions xlabel, ylabel, and zlabel for three-dimensional plots, and that puts a label on each of the axes. So we'll use an example, and we'll say one is time and one is position. So we'll do this just for fun. So it's also generally to put a very good idea to put the units on each axis label so you know what units are being shown in the plot. Okay, so we're going back to the example we did before, and this time we're going to say, okay, we're going to say that the x-axis represents the time in some sort of time in seconds. So we'll say time. Usually in parentheses you put the units. And it puts a label on the plot. Surprising, right? Well, it shouldn't be. And then the ylabel. We're going to, what was this? Position in meters, let's say. And that now you have you can see now you have an axis, you have the function, you have an x label and a y label. So what else can you do to your, would you like to do your plots? Well, let's take a look at that. Okay, so one thing you might want to do is put multiple plots in the same graph. There's all kinds of reasons you might want to do that. So from that, you use the function hold all, and we're just going to show how that works. Okay, so let's start basically from scratch here. So we'll do a clear all, close all. So let's see. Okay, so we're going to do something similar, except this time I think we'll have x go from minus pi to pi over 50 to pi. So now I'm going to do a figure, and I'm going to plot x sine x. So that plots the sine function. Well, what if I'm going to do another plot on the same axis? I'm going to do hold all. And then for each thing you do after this will be on the same figure. So now I'm going to plot x and cosine x. Okay. So we'll say for some reason, well, let's call the let's say the x-axis, xlabel, we'll call it angle in radians. And we'll say the ylabel is, I don't know, something. I don't know. We'll call it something. It's called displacement. And say maybe we've got two things that are sort of doing sinusoidal oscillations or something. So we want to put a title on here. What would be a thing we could call this title? We'll just say sine and cosine versus angle. And of course, I forgot the first. But now we need to know which is which, and that's where we're going to get into another function called legend. So you want to put a legend on the plot. So legend, you just put a bunch of strings in here. We're going to call this. The first one's going to be cosine of x, and the next one's going to be, call this sine of x, and then the next one's going to be cosine of x. And that put a legend, so now you can tell which plot is which on the plot. So another thing you might want to do to format your plot is you might want to put a grid on the plot so you can maybe see things better. The function for that is grid on, and that will put a grid on your plot that corresponds to your major axis on your plots. Okay, one thing you might have noticed, we didn't have control of which color is what, but we might want to control which color is what. This is done with a format string in the plot function. So if you put an extra variable, a string in there that says R, it'll plot the data in red. G would be green, B would be blue, K black, Y is yellow, although I don't recommend doing yellow plots on a white background, they're hard to see. M is for magenta, C is for cyan, and W is for white. And again, you don't want to do a white plot on a white background. You'd have to change the background of the plot. We'll talk about that maybe in a later episode, but that's we're just doing the basics in this particular one on how to plot functions. Okay, so we're going to do this. Let's do this again. Clear all, close all. So you'll see we're going to do the same sort of thing. We're going to do x equals, I don't know, minus pi over 50 pi. And we're going to say y is sine of x, and let's say y2 is cosine of x. We're going to do a figure, and let's say we want to plot the sine function in red. We would plot, what we do, we would go plot let's say x, y, red with R, and that'll plot it in red. So now we're going to do a hold all, and let's plot the cosine function, and oh, I don't know, let's say green. And there it is in green. Well, we could also plot, oh, I don't know. We could plot x y squared, and let's say cyan, just for fun. And you can, now you have control of what colors are what. So if you want specific colors, one reason you might want to do this, if you're plotting like the same sort of thing, or for the same, if you want to keep multiple plots to be consistent with each other, you might want to control the colors. There's all kinds of reasons you might want to change the color. And we're going to go into some other things you can do. So there's one of the options here was just, geez, they're just lines basically, but you can do other things for plotting. Okay, so what you can do here, you don't have to have a straight line. You can do a dashed line. You would put an R and a dash for a red dashed line. Double dash indicates a double dash line. Well, okay, sorry. So this is a single solid line. This is a dashed line, 2 dashes. This is a dotted line. You just use a colon to indicate a dotted line. And basically, a dash dot is a dash dot line, and we'll show how that works. So we'll do the same thing we did before. We'll do x equals, I don't know, 0. No, let's do the same thing, minus pi. Pi over 50, pi, just we could, you know, you could make anything here, but, and we're going to do y equals sine of x. Figure. Okay, so now we're going to plot x and y. But let's say we want it to be green and just a line. That won't change it. It'll just change the color. Now let's make it a dashed line. So now it's a dashed line. Let's make it, I don't know, a blue dash dot line. Or let's say, I don't know, a red dotted line. There we go. So that shows all the different types of line types you can do. So you can also do something to show the points that you have, and we'll show you that now. Okay, so now there's all kinds of things you can use to mark the points that you actually have that are not connected. You could use in Octave. This is the set that you have. Some of them are the same as in Matlab. Some of them are the same as in Scilab. Some of them are different. So most of these are the first ones are the same. But if you want to be sure, you do doc plot, and it will tell you what all the options are. So let's just go straight to the demo for that. That's pretty easy to do. Okay, so now we're going to do, let's see, clear all, close all, CLC. Okay, so now we're going to do more of the same. We're going to bring back our y equals sine of x. And we're going to bring up a figure. So now, actually, let's do something different. Let's do x, let's be a little bit more coarse. X equals minus pi, let's say pi over 4 pi. Y equals sine x. And then we'll just plot x, y. So that's a little bit there's not as many points. But if you wanted to actually see what the points look like, just where the points were, you can do plot x, y. Let's make it green just for fun, and we'll do a just plot the points as an asterisk. And that puts the plots. Now if you want to actually connect the lines, you can do this. And now you've plotted the points and you connected them with lines. You could also do something like what we did before. You can connect them with dotted lines. The other thing you could do, if you wanted to do the lines in one color and the points in another, you could do plot x, y, red star. That only plots the points. Oops, but before I do that, I do a hold all. And I'm going to do plot x, y, red star. So now it plots the points in red and the connecting lines in green. You can do all kinds of things like that to mark the points on a plot. Okay, so now we're going to talk about plotting a 3D line. So you use the plot 3 function for 3D thing, and you just plot 3 variables. And this will just plot a point. There's 3 arrays. They all have to be the same size. This will plot a line between each point. So you can actually do all the things you talked about with the other plots, with the 3D plots, with the format string. So we'll just show how that works now. Okay, so let's close all. Let's see. So let's make x go from, I don't know, 0 to 0, x equals 0 to pi, let's say over 4 to, let's do something like 5 times pi. Okay. Let's say y equal, let's say sine x. And let's say z equals cosine x, just to be fun. We're going to start a figure. So we're going to plot 3, x, y, z. So that plots some sort of spiral. So, and you probably want to do something like this, xlabel. Let's say x is, let's say x. Let's say this is a position. This is sort of a trajectory or something. Or just, let's make it x and then ylabel. So now all the axes are labeled. Another thing you can do with these types of plots, well, you can sort of change what direction you're looking from. You can do that in any of the software that we're talking about here. So you can see what that looks like. So it is really a 3D plot. Let's see, we could do a hold all. And let's say we just wanted to plot 3. We wanted to do the same thing we did before and make all the points asterisk in red. We can do the same thing. We can plot 3, x, y, z, red star. And now you have all the points in red and the connecting lines in blue. So this shows you some of the things you can do with plotting a 3D line. Okay, now we're going to talk about how to plot a surface. It's a little bit more complicated than plotting a line. So a surface is something that can be represented by some variable z equals f of x, y. there are two functions for plotting surfaces, surf and surfc. The difference is surfc plots things in color. Now all these arrays, the x, y, and z, have to be rectangular arrays. So that's a little bit more complicated. They have to all be the same size. They have to be rectangular arrays. So first step is to set up an XY grid that we'll use to compute the height of the surface from. For this, you use something called the mesh grid function. So what you would do is you would pick the ranges you want for your x and y variables. Here's an example. And then you say, okay, now I want x and y to be the mesh grid of that. Again, here's the case where I did something where case is different. You can, if the small letter x, lowercase x is different than uppercase x as far as variables concerned. So we're going to compute this function z equals sine x times cosine y. So let's see what that looks like, since we're just sort of keeping things in sine and cosine for the moment. Okay, we're going to start over, so we're going to clear all, close all, CLC. We're going to, so x equals minus pi, let's say pi over, I don't know, 10 this time, to pi. We're going to make y equal the same thing. Then we're going to have x, y equal mesh grid x, y. So, okay. And then we're going to do z equals sine of x times cosine. We'll make a capital Z just to make it be consistent. Cosine z, cosine y. So now we're going to do a surfc x, y. Oh, sorry. First I got to do a figure. Surf c x, y, z. And that's what that looks like. And we can rotate that around and see what that surface looks like. We can do things to eliminate the lines if we want to. The other thing we can do here is we have these colors represent heights. If we want to figure out what those colors mean, we can use the function colorbar. If you do colorbar, it'll tell you what the colors mean in the plot. So you can actually look at it this way, or you can just rotate it around and you can see what things are. But now that I've rotated a bunch, I don't know what axis is which, right? So I will do that xlabel. This is one of the reasons why you want to xlabel things. Let's see. So I'm sort of being arbitrary here on the units and all that, but that's okay. Oh, I didn't need to do semicolons there, but that's, so anyway, now you know what the axes are and you can rotate it around and you can see. Notice how it puts like a contour plot on the bottom. But this is a useful thing when you want to plot a surface. Okay, so we've gone through all the basic line plotting functions: plot, semilog x, semilog y, loglog, and plot 3. Surface functions, surf and surfc. Colors, we went over colors. We went over line styles, point markers, labeling your plot, formatting. You turn on the legend, have a legend, color bar, or grid. And this covers the basics of plotting. Now there are other things you can know about plotting, but this is enough to get you started to figure out how to present data that you're either analyzing or creating through simulation or something, or if you just want to do some fun things with math. So we have some exercises here. So here's some things. We're going to plot some functions here. Hint, these things have singularities in them. So you might want to avoid plotting near those singularities. But, if you do that, then you can have something that looks reasonable probably. Or you can plot whatever function you want on whatever, and then to play around with that, put titles, axis labels, legends, plot a 3D line. This is the thing I did in my demo, and plot the surface. So this is fairly straightforward. It should be fairly easy. If you don't understand it, watch this again. You can always use the help or the doc function in any of these, Matlab or Scilab or Octave. And that's it for now. So we'll see you in the next episode.